we're going to look in this video, we're going to look at problem number 3. Problem number 3 here, which is the shaft is subject to an axial load of 5 kilonewtons. We want to determine the bearing stress on the collar A and the average shear stress where the collar and the shaft are connected. So we basically have this load here of 5 kilonewtons. So that means if we look at, say, a free body diagram, perhaps of this part right here, we will see maybe cut this off right here. And so you see this reaction here. This is 5 kilonewtons. And then down here, this is 5 kilonewtons. Here. Now, these are not two separate forces. It's just like one force along that collar. And now the bearing stress is going to be the stress along the face of this collar here. So if we were to look at, say, look down here at this collar, .65 meters going to be the diameter of the inside of that collar. Excuse me, yeah. That should be a 0.065. So then here, this is going to be 0.065 meters. Is this collar here. And then the outer diameter of that is going to be 0.1 meters. Like that. So there's going to be like a 5 kilonewton force on that face right there. And so we want the area of that face. And that's going to be pi over 4 outer diameter squared minus the inner diameter. And that area is 0.0453 meters squared. That's going to be this area here. And now again, there's 5 kilonewtons on that, or 5,000 newtons. And that'll be our bearing stress. It's going to be that force divided by this area here. That's going to be like 5 kilonewtons divided by that area, 0.00453 meters squared. And when you put that in your calculator, you get 1102 kilonewton meters squared. So that's going to be for part A That'll be our bearing stress. Again, it's sort of the stress, by that contact surface on that face there. The part B wants the shearing stress. So that's going to be like the stress that's generated from like this inside trying to be pulled out of the ring. In other words, it's almost like this shaft wants to be ripped out of that ring. So let's take a look at that. And so therefore, what's going to resist that is going to be this inside diameter of the ring. So for part B, we maybe take sort of take a snapshot like this. And this diameter here is going to be 0.006 meters. And the width of this is 15 millimeters, or 0.05 meters. So again, that it's as though that shaft is trying to be ripped out of this collar. So the area resisting it is going to be this circumference times the length. So the area that's going to resist the shear will be the circumference pi d times this length. That's going to be 0.009, and I'll leave the pi in it, pi meters squared. And then, so the shear stress is going to be equal to the force divided by the area, which is going to be, once again, 5 kilonewtons divided by that area, which is 1768 kilonewtons.